As you travel from the zero potential to the positive potential, one electrostatic physical quantity stays perfectly constant, while another electrostatic physical quantity steadily and uniformly changes. Let us investigate in this question. So I have given you, this is a diagram given us in the question. So let us say if this is a charge that is going from a 0 volt to some higher potential V, and it is going by any means, we are transferring it from this point to another point. So how does the potential changes and how does the electric field changes, or does it stay constant? Let us investigate. So whenever we produce a potential difference between the two plates by connecting the two parallel plates with a battery, so let's say the one plate develops a higher potential and another plate develops a lower potential comparatively. Now for the parallel plates, the field between them is uniform. And how do we represent this uniform field? We represent it with the help of these parallel lines. Okay. And why parallel lines? Because the field is constant irrespective of the position of a charge. Whatever point you take between the plates, either that point is close to this plate or the point is close to this plate. At both of these points, the electric field is constant. Now, we will debate about the reasons. Now, why the electric field strength is constant? Because the important reason is same electrostatic force is applied at both positions on the charge, right? Can I say E is equals to, since according to its definition it's electric field strength, so it's the electrostatic force applied per unit charge. Secondly, don't forget that electric field strength is a vector quantity and it is directed from a positive to the negative plate. So, since its direction is not changing and a vector can change even if its magnitude is constant, but if its direction is changing, then this factor can make it non uniform. And exactly what we observe. Dear students, we observe this thing over here on the edges of the plates where the field lines are not uniform, they are not aligned. So that's why electric field is also non-uniform, because electric field's direction is changing at every point. That was my point. So electric field strength is constant between the plates. Okay, so this is a first reason. And the second reason is, dear students, now if you look at these parallel plates, where if I try to show you that actually how the electric potential changes from 0 volt to the maximum value, because this electric potential is the work done per unit charge. So as you move the charge from a zero potential to the maximum potential, this work done increases, means the energy stored in the charge increases if it is a positive charge. So I can show you exactly in the middle, when the distance between the initial point and that point is, let's say, the x over 2, whereas the x is a total distance between the two plates. So exactly at that point, dear students, the potential is half of its value. So it means that, so if I try to find out the E, which is equals to V over D, generally speaking, according to your IB data booklet. So if you apply this equation, so in the middle, since the potential is half and the distance is half as well, so that's why the electric field strength is still same. So you can take at any point. If I draw another equipotential surface at that point, the distance from this to this point is 2x over 3, means 2 2/3 of that. So the potential will be equals to 2v over 3. Once again, if you take a ratio, that will remain same. So it means that if E is constant, so if E is constant, which means that the V is proportional to X. Okay, so just the last thing, I want to show you the results in a graph. So the electric field strength does not change, it is constant if the all the lines are parallel. And secondly, the potential changes uniformly. So I'm drawing this graph, but remember, I am just showing you the magnitudes. I'm not relating the negative sign in electric field strength formula, which relates with electric potential. This video is generally for both HL and SL students. So the potential is proportional to X and electric field strength is constant. Okay, so the right answer is option B, which says these two things.